back to my class. And if you remember the last class, I have asked you what will be the final answers. Anything in the comment that need to be learned? Okay, so whatever you will type in the comment, I will reply in the comment, okay? Anyhow, so if you will be like, what I will say to this, what is happening here, so you can do it in a way like, yeah. So integer star 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 pointer is equal to end of the pointer, and then I can say integer pointer equals to 100. So what will be the outcome for it? I have to look back to this diagram, which is already looking so looped. I'm going to use something which is right. Oops. Yeah. So when I'm saying star 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 pointer, so another pointer is created. So whenever you are saying initialize, doesn't matter what name you're putting, it will again create in your memory. Understand? Correct? So it will be created in some address, for example, 3000. And when I'm saying pointer, so this is like pointer. So pointer star is storing the address of the pointer, and which will reference to the direct address of this pointer, which is storing, like, which is just before created. And this could go as here. So when I'm saying star of the pointer, so it's storing the value which is like 8000. So when this pointer is pointing to the 8000, so 8000 is actually then again this reference, because of the other reference, we will also get inside what 2005 is storing. So 2005 is storing what? Is storing something inside it. For that, we have third pointer to access that, which is like 5000. So we have reached here. So 5000 is here. Now, another line is saying this star 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 pointer need to have a value 100. So when I'm saying star 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 pointer, so it means 8000, which is referring to 2005. 2005 is referring to 5000. This is need referencing here, need to change from 30 to 100. So the final value, what variable now will be having 100. So whomsoever gave the right answer, kudos to you. So why I was teaching you pointer in a data structure classes, because we're gonna learn very soon about arrays, stacks, queues, and linked list, trees, and graph, which all have implementation using the pointers. Even the arrays can be implemented using the pointer. It's a very crazy area. I would not like to cover it because it's a bit complicated and it's more advanced, and I'm not sure how advanced you really want to. But if you really want it to happen, just write down in the comment below, you know the drill. And I would be really covering like how this pointers, like when we going to dig on the pseudocode of creating a linked list with the nodes, with heads, and the referencing to the next of the pointer. We will be using this word in like all the time. So that's why for me to give you a brief of pointer is very, very important. Although there are many other videos in the YouTube that you can really see, but I would suggest here the elaboration is more visual compared to all the other videos. So stick to it. Now, pointers can also do arithmetic operation. You know about arithmetics, like plus, minus, yeah. So here we can first increment and decrement the pointers. These have more usage when I'm teaching programming. So I'm not gonna go in depth about it at the moment, because when we learn when we do the C++ programming or C programming, I think that time I will give you more descriptive explanation of it. But for just knowing, this is enough. You can add value to pointers, to integer pointers. You can subtract value to the integer pointers. You can subtract two similar pointers, and 3, 4, and 5. You can compare pointers, two pointers. So in compares, it is like less than equals to, greater than equals to, less than equals to, and not equals to, or equivalent. So all these things you can do using the pointers arithmetic. And yeah. Now, what are the features that you think it's very important? So features of pointers. First of all, it saves memory space. Because once you are creating a pointer, you're just storing the address of that type. So whatever the address type it is, like integer or float, you're just creating the same space. So it could be 8 byte to 4 byte to 2 bytes. So it could be just that much of a space. So you don't have to really create a big array or things like that, because it's not very static, it's very dynamic. You can deallocate the space also when you feel like, it is not needed in my memory, right? So it saves a lot of memory space. Execution time is very less. Execution time is less compared to variable. So if we see the condition of the pointers, you can easily access the memory location. You can also access the variable very fastly. Provide direct access to memory location, and you can efficiently, I told you data structure is all about efficiency. So efficiently you can access memory and even dynamically allocate. What does that mean? Like, to access the memory, you can access any memory, doesn't matter like where it is stored, how far it is stored from each other, whether it is like, next to it or in somewhere else. It is can be easily accessible, and also dynamically means, for example, I was writing a program. I felt like, okay, I have nearly 1 lakh of codes, and already I want to create some space to edit some kind of data. Means I just want to have a space, I want to create a space to store my, like, I'm creating an e-commerce site, and I didn't create it as a space for my makeup and how I can, sell my makeup products. I have everything, but makeup was not there. Already I have written so many codes, and to edit this part, which is like dynamically I have to allocate some memory space in my data set, I can easily do using the pointer, which can easily access somewhere in my code. I can fix it like, oh yeah, pointer point to the makeup, and makeup can be easily created, can be accessed, can be updated whenever it is needed. So I don't have to change whatever the memory assigned earlier to it. And also I can access those already created memory from it. So that's the beauty that pointer gives in your program. So when we will study trees and all, you will see like, oh yeah, it gives that kind of, visualization of how you can access the memory in a very dynamic locations. Hmm. Um, when we have two-dimensional and three-dimensional type of data structures, the access become also very easy using the pointer, which I'm already told you, like in, for example, when I'm having trees kind of structure. And even the the elements that you stored in your arrays can be accessed easily using the pointers. So for example, in array, when you create, if I want to update anything which is stored in the random location, if I want to delete it also, it's a lot of editing that I have to do to make that edit. And um, high chances I will miss that position. But using the pointer, it is very easy to access, to update, and to delete whatever the elements that is stored in the middle part, or like in between the front and the end. So it's always easy to access the front and the end of the array, but what's stored in the middle, like n-1, is always very complicated. Hmm? Now for file handling also we can use um, like we do use pointers. And yeah, so more or less, like these are the features that pointers are really used for. If you have any doubt in any of these points, feel free to write in the comment. Um, with all these benefits, we also have some problems. So what are the problems that pointers really face? Can you tell me? Hmm. Yeah. First of all, pointer is only dealing with locations. So incorrect pointing of location variable of location gives wrong value, right? So if I wanted to point to the pointer of like if I'm saying point, if I'm referencing to a pointer, but I mistakenly referenced to the address, but it was like double referencing, it's a problem, right? Um, if we have error input, the output is also error. And most of the time, the output that you get as error is very hard to debug, because it will just say the referencing in this line is not correct. And then if you're not sure about how this referencing is really happening, so please revisit the video where I taught you how the referencing happens. You can easily debug that problem. Wow, this is very important, that uninitialized, uninitialized pointer leads to segmentation fault. Means whenever you have uninitialized, like you just said, star pointer equals to 20, it will be like, why, where is the initialization of it? Where is int star pointer, with to whom, which address should I make it 20? Because it's referencing, when you say star pointer, it's not just an integer. So it will be like, where do you want to, where should I go? So that's the error it gives you. Okay. It is also slower than normal variable, because if you're having like a lot of pointers together, like pointers to pointers, and then you want to access that, like, that memory space where you have stored a particular element, it will take certain time because it has to reference to all the memories, and it takes some time. But it's also very debatable based upon the problem that you're trying to solve. So it's not like in all the problems you're going to find that, yeah, it is very slow, but in certain situation you have to take the chance. It requires you to deallocate, or you can say dereference point. So whenever you're creating a pointer, it's good practice to delocate, yeah, dereference it. So in that way, you free up the space, and in that space, you can store any string or variable for the later purpose for any other uses. So this is also very, very important, but it's also a very critical point when you're doing the pointers. It helps you to, maintain this kind of habit. And if you didn't deallocate, didn't happen, we have memory leak problem. Ugh, not good. So we can have a memory leak, which is like this was a certain space created, but it was never used, and it is referencing to something which is now not created. Like, why this is dangling in my space? Why? And that is kind of memory leak because it's become so useless that nothing can be accessed. It's just unnecessarily space is being created, and it is like, like just being misused for no other goal. For example, in your daily life, when you are using your mobile phone, so in your smartphone, you open lot of pages, like you open Instagram, you open YouTube, WhatsApp, and things, and everything is running in the background, if you know. And if you do not close this application, it will keep running in your background, and unnecessarily it will be taking the space. And you feel like your mobile is getting heat or it's getting slow. So you will be like, hi, this is kind of a memory leak, which you can visualize and see it in real life. So that's why you always close all these apps. Otherwise, it will be like, hey, your memory is full. There is so much cache is being collected in your like, in your um, mobile device or mobile disk. So same thing when you're creating a pointer while you're programming for some application or something, you must deallocate it. If you do not, there will be a memory leak. But it won't happen when you're creating just like, if you're creating a program of 100 KB. No, but if you're having a bigger program which is more than like 8 GB space it's taking. So when you have the practice of writing program in certain manner, you can avoid the bigger challenges in writing those programs. So right now we are only focusing in the pseudo code. So obviously you don't have to really learn about how programming is working. When we go towards the application side, we will surely see how these tools can be used in more perfection. So for now, this is what pointers is all about. If you feel like I have missed any point or you want me to elaborate any point, please write to me at learnziel@gmail.com, or also you can email me. For the rest, keep keep following us and subscribe to the channel. Thank you and ciao.